register caredev region or register child region. Okay, so this is one way where you register your driver for the major minor number. So when I say registering your driver, typically we also use the terminology like you are registering a device with a VFS using this interface. That's why the term register care device region. I'm supposed to serve this particular uh, file which wants to operate on this particular device. Now what you do over here, you basically provide the first argument as devt. That means 250 comma 0. I want to serve any file which is bearing the major minor number 250 comma 0. And then next thing is, how many functionalities do you want, how many device files you want to serve. So you are specifying over here 3. So when I come to my multifunction printer functionalities, so what I would like to say, over here is, so I would like to say I want 3 functionalities over here. It is like this: 250 comma 0, 250 comma 1, 250 comma 2. So these are the 3 device file interfaces which I want. So this is where you specify like how many interfaces do you want. And another thing is the label, what register, what name you want to give it to this particular stuff. So now this looks fine. Let's say what you are specifying is I'm supposed to serve 250 comma 0, and as long as you are basically falling into this standard category, like let's say your driver is a standard driver which is serving the standard category of a devices, that still works fine, where you have hard coded the major number, where in a driver itself you have hard coded the major number. So now what we are saying over here is I will be the one which will be serving 250 comma 0. So see, when it comes to the standard category of the devices, we have the major categories defined. Let's say 4 for TTY, and let's say 8 for SATA kind of, or I can say SCSI kind of devices for the block device and all. And let's say for the sound devices, sound category of the devices, we have something like let's say take one hypothetical number. This is for the sound category. So as long as the standard category is defined, yes, that will work fine. That means you are basically giving a hard coded number. But let's say you are writing a driver which is for your LEDs. Now LED is a very non-standard kind of device. There is by default, when you are writing a driver in order to control the LED, or let's say any sensor you have taken and you want to define a major number for that, so it's a very non-standard kind of thing. And if you hard code over here 250 or something, there is a possibility that if you mm, take your driver to other system, this 250 might have already been taken over by some other driver. So it might be serving another functionality. So what I'm saying is, when I say 4, it is defined that it is for TTY. When I say 8, it is defined it is for the DSP. If it is 12, if it is defined that it is for the sound and all those kind of things. But what about the non-standard devices, that your whatever driver you are writing is for the non-standard devices which is not being defined by any standard framework. And in that case, if you take 250 comma 0, let's say for your LED driver which you are writing, let's say somebody else has written the driver and he's using 250 comma 0 for his another sensor, then what will happen? It would be the clash. And as I told you, in a system, you can't have multiple drivers serving the same major comma minor number. Same device file can't be served by two drivers. So what will happen? The registration of your driver will fail. So if on your system 250 is free, if you are using it perfectly fine, it will work. But let's say you hand over your driver to someone else. Now that guy already has a driver which has the number 250 comma 0, but it is serving a different functionality, so your driver will fail. So that means the probability of your driver failing is high, or in other words, I would say your driver is not portable when you are statically hard coding the major minor number. Does it make sense? How do we tackle this problem? See, in order to tackle that problem, you have one of the way that you have something called cat slash proc devices. When you go to the cat slash proc devices, what you are going to find over here is, over here you see it says what all different major number has already been taken. So for example, this guy has taken 4, tty has taken, ttys has taken 4, tty has taken 5, then tty print k has taken this, misc has taken 10, and all those things are, all these are the major number which have been already taken over by other drivers. So what you need to do, basically you can do cat slash proc devices and figure out the available measure number somehow, available measure number, and use the driver and basically create the driver with that thing. But when it comes to from the customer perspective, that's very cumbersome. Like, I can't ask my customer, okay, look into your system and tell me like which measure number is free and you just register for that. That's not possible for the customer. So that means when you have a static kind of measure numbers, there is a limitation that it might fail due to any other registration. So if I want to make a my driver portable, what I can do is I can allocate the major minor numbers dynamically. That means, what do I mean by dynamically? I leave it to the kernel. I tell kernel that I don't care about what major number I get, because I am just writing a driver for the non-standard device and I don't really care which major number I get. You give me any major number which is available currently in the system. So sometimes you might be getting 240, sometimes you might be getting 250, sometimes you might be getting 260, or whatever major number. But what I care about is the first minor number which you are going to give me as 0. Okay, and I want the minor numbers from 0, 1, 2. So in this case, what will happen is, what I'm saying here, that my major number can be 260, or it can be 270, or it can be 280, because it is dynamically allocated to me. But what I'm guaranteed to have is, when I get 260, along with that I will get the minor numbers 0, 1, and 2. So even if I get 270, 0, 1, and 2, I will get it for that major number. So that is what is the dynamic allocation mean, where I'm not attaching my driver to the particular measure number, because there are chances that I will fail because I'm writing a non-standard driver. But at the same time, what I would like to say is, I want to keep it open. Any measure number available, you give it. But I'm very strict that I want the first minor number as 0, and I'm registering for these minor numbers. So as I have this character driver, and what I'm going to do is, over here, I'm going to register my character driver with, so what you have got is, you have got the apis.txt over here, apis.txt. Just need to refer this. And what first thing which I want is alloc chardev region. So let me just show you. What I will be doing is dev t, I will leave it to the kernel. You give me any major number which is available to you. I don't care about what major number I get. What is the first minor I want? Let's say 0. When I say what is the first minor I want, what I'm saying is, I want to serve a device file which bears this major minor number. Okay. So I want to serve a device file with the measure number which you will grant me, which you will basically provide me, 250, 260, and under that I would like to serve 0, 1, 2. Okay, that's why I'm saying 3 over here. And what I'm doing over here is, let's say the label which I want to give is like my car label to this registration. Okay, and in the exit module, what we are going to do is, we are going to deregister is, okay. So Again, for deregistering, the API is unregister caldev region. So I will come here is I have first and all the three instances I want to deregister over here. Okay, so this is how you will basically call register and unregister your driver. Now let's see one example and then the things will be more clear. What I've done is over here, I'm going to show you all the examples of my BeagleBone Black because sometimes if I make any mistake, for instance, it will crash. So I don't want to disrupt this meeting. So that's why I'm doing this on the BeagleBone Black, but the same thing you will be doing on your virtual machines or your systems. Okay, so right now what I will be doing is the output is going to remain the same. So that's why I thought like let me not disturb my system since the meeting is going live over here. So I'll come here and I have transferred this to my BeagleBone Black, and here I'm going to do first char driver.ko. Okay, now see what has happened. So you see, I have been assigned a measure number 247 because that was freely available to me. I told the kernel, I don't care about the measure number, whatever you want to give, you give me that. And under the slash proc devices, when I see over here, my chair, we use this one, right? My chair as a name. Under this, we have got this registration. That means the system has registered your driver for serving a device file with a measure number 247. Now, when I do RM mode and I check my care devices, 247 is not available. 247 is not available right. Oh, I mean, there's no driver which serves 247. So now there is a high probability when you do the ints mode, you get the same measure minor number because that is available. But let's say in between I inserted another driver, so you might get another number. Okay, so that's what I'm trying to make. Now we have got 250 comma 247 comma 0. Does it means that the device file will appear with a measure number 247 comma 0 over here? Let's see. So if I do ls minus l slash dev and I check for what all different device files I have got over here, what all character special files I have got over here, let's see. And if you see over here, I don't have any device file which is having a measure number 257, 247, right? We don't have any device file. So what do I mean by that is when you register your driver, when you register your driver, device file is not created. Your driver by default doesn't create. Registering a driver doesn't means that the device file is created. Okay. So one thing you need to bear in mind is the registration of a driver has nothing to do with the creation of the device file. So as I told you in this slide as well, all these three entities are independent of each other. That means I can register my driver with a VFS, but that doesn't necessarily means that slash dev ABC will be automatically created. No, it won't be. So fine. Let's say I want to operate on this driver. What should I do? So now the burning question which we might have is I created this driver without device file. How do I interact with it from the user space? So you see, right now what we got is when we registered our driver, it told us, it gave us the information that 247 comma 0 is where I will be providing my services. Okay, now let's come to the point. We have my first char driver.c, which is registered for 247 comma 0, and we have the my first dot ko, which is registered for 246 comma 0. And when you will look into the device file, when you will look into the device, there is no device file with these numbers. Okay, there is no device file with these numbers. Okay, it doesn't exist. So the point which I was trying to make, as I told you, creating a driver doesn't necessarily means that the device file will be created, because device file is in the user space. So what you need to do, you need to manually create the device file. For example, when we loaded it, this guy, or from the cat slash proc devices, cat slash proc, I have got, like, if I want to interact with this driver, 247 is basically the number. So what I will be doing, there is a command by name mknod slash dev. I can give any name over here. Let's say I'm giving a name over here. It's a file name, right? Uh, my device, my device. C 247 0. Okay. When I do slash div, my device, what I've got, character special file bearing the name my device, bearing the major minor number 247 comma 0. And we know that it's our driver which is supposed to serve that. So that means link with a VFS. That means when you register your driver with a VFS, you told I am responsible for 247 comma 0. Now in the user space, you need to create the device file with that major minor number.